Okay, dear students, in this video, we are going to start revise moles and molar calculation. For this, I would like to open revision checklist. If we see in revision checklist, the first point in revision checklist is that state that the mole is the unit of amount of a substance. One mole contain 6.02 into 10 to raise power 23 particles. For example, atoms means what are particles? It could be atom, ions, molecules, formula units. Okay, and this is Avogadro constant. In simple words, if I can explain it to you, if a substance contain 6.02 into 10 to raise power 23 units, particles, these particles may be atoms, molecules, then this is equal to 1 mole. In other words, if the mass of an element, atom, or molecule is represented in gram, this is equal to mass mean AR. MR is represented in gram. This is also equal to 1 mole. And this is very obvious from this formula. Mole is equal to mass over MR or AR. Okay. What is the meaning of this? If you see sodium, its AR is 23. Okay, if suppose mass is 23, its MR is also 23, sorry, AR is 23, then what are the moles? Obviously, this is equal to 1 mole. So from this, we can define mole as well, that if AR or MR of an element or a molecule is represented in gram, this is equal to 1 mole. Okay, hope you are clear with this formula. Or in other words, if a substance contains 6.02 into 10 to raise power 23 particles, which is Avogadro number, this is equal to 1 mole. So this mass, molar mass, relative atomic mass, or relative formula mass is clear. Relative formula mass is used for ionic compound. For ionic compound, we cannot say MR or molecular mass. Number of particles using the value of the Avogadro number. Okay, what is this? From this above definition, what I said, if a substance contain Avogadro number of particles, this is equal to 1 mole. We can use this very specific definition. Number of particles is equal to mole into 6.02 into 10 to raise power 23. What is the meaning of this? If 1 mole, then 6.02 into 10 to raise power 23, which is definition. If not 1 mole, 0.5 mole, then what are the number of particles? 0.5 into 6.02. You know, this will be the half of this one, which is 6.02 into 10 to raise power 23. The answer is 3.01 into 10 to raise power 23. Hope you are clear. Same way, if you are given the particles, not number of moles, then how you can convert this formula? I would also like to show you this one. For example, number of particles are not 6.02. These are 12.04 into 10 to raise power 23. And he's asking what are the moles. So you can calculate moles with the help of this formula. 6.02 into 10 to raise power 23. This 6.02 is shifted to other side. And what will be the answer of this one when this will shift to other side? We can write this in this way: 6.02 into 10 to raise power 23. So the answer of this one become 2. Hope you are clear with this. All examples with the help of Avogadro number, with the help of mass, we can calculate moles. We also see these in past paper questions. I will show you this. Okay, now what is next in revision checklist? use the molar gas volume taken as 24 dm cube at room temperature and pressure RTP in calculation involving gases. Okay, now this is about gases. This means if a gas has 24 dm cube volume at RTP means 25 degrees Celsius and atmospheric pressure. 24 dm cube are 24,000 centimeter cube. This gas is also equal to 1 mole. That is 24 dm cube is molar gas volume, or 24,000 centimeter cube is molar gas volume. Molar gas volume mean mole volume of a 1 mole of gas. So what is the formula for the volume of gas? From this definition, we can conclude volume is equal to mole into 24 dm cube. Again, if 1 mole, the volume of gas is 24 dm cube. If it is 0.5 mole, 0.5 multiplied by 24, this is equal to 12 dm cube. Hope if you are given the number of moles, you can calculate the volume of gas. Remember, this is used to calculate the volume of gas, not the volume of solution. Some students wrongly what they do, they put the moles in the volume and concentration formula. We will see this in next topic. Okay, and this also be used to calculate the volume of gas if suppose you are given the moles. For example, what is the volume if moles are 0.25 multiply by 24 dm cube? So you can calculate, this is same like this one. And if you are given the volume of gas, you can calculate the moles of this specific gas. How this could be? For example, volume is 36 dm cube. So what are the moles for 36 dm cube? If 36 dm cube, you have to write it 24. 36 divided by 24, you will get the answer 1.5. So hope you are clear with this molar gas volume and molar gas formula. And next is calculate the stoichiometric reacting masses, limiting reactant. Yes, we will see the question related to limiting reactant, the volume of a gas at RTP, volume of a solution, and concentration of a solution in gram per dm cube and mole per dm cube, including conversion between centimeter and dm cube. Okay, I would like to show you this. First, we should know what is meant by concentration. Concentration, amount of solute in a given solvent. Normally, it is taken as the solvent is taken in 1 dm cube as 1 dm cube. For example, NaCl, we take the example of NaCl. 58.5 gram of NaCl is in 1 dm cube. In shorthand notation or in concentration representation, we can write it 58.5 gram per dm cube. Now the question is that, sir, concentration is in mole per dm cube. How you can write this in gram per dm cube? Yes, concentration can be in gram per dm cube. This concentration is called in mass per dm cube. You can convert this concentration in mole per dm cube. How you can convert? You have learned that we can convert mass into mole by dividing mass with its formula mass or with molecular mass. In case of NaCl, we will say it is formula mass. The formula mass of NaCl is also 58.5. Its mass is 58.5. So you can say the concentration in mole per dm cube is 1 mole per dm cube. Hope you are clear with this concentration concept. Calculate the empirical formula. We did this in previous video. I also explained when we see the questions in the past paper. Calculate the percentage yield, percentage composition by mass. Yes, whenever you have given the appropriate information, for example, I would like to write the formula percentage yield is equal to actual value. What do you mean by actual value or experimental value? This is the value which you calculate in lab actually. And what do you mean by theoretical value? I would like to write this way. Theoretical value means the value which you calculate from balanced chemical equation. This is theoretical. In ideal condition, okay. I would like to share it again to you. Percentage yield is equal to actual value divided by theoretical value multiplied by 100. Okay. When we have question, we will see how to calculate it. I would like to shift on the questions, and this will be shown in the next video. Hope you are clear with this explanation. A little information, not very complete. You can understand it with the help of questions, which we will do from past papers.